Today's our introductory lesson to trigonometry, and we're going to start off for our first few lessons looking specifically at the trigonometry of right triangles. So in general, trigonometry looks at the relationship between angles and side lengths in triangles. And we're going to start off looking at our triangle ABC that we have drawn on the left here. So the triangle is already labeled for us with the uppercase letters at the vertices or the corners of the triangle. And we can use those uppercase letters to refer to the angles of the triangle, or we can use our symbol here of theta. And I've written the symbol of theta here with angle B because we're going to be using this as our reference angle. So we are going to label the rest of our triangle, and we are going to be giving names to the sides of the triangle with respect to the reference angle. But before we even do that, we are going to start off by labeling the hypotenuse. So the hypotenuse is the longest side, which is across from the 90-degree angle in the triangle. And then we're going to label the other two with respect to the reference angle, because the hypotenuse does not change even if the reference angle is elsewhere, but the opposite and the adjacent side are labeled specifically with respect to the reference angle. So we look at our reference angle, which I'm calling theta here, and across from theta we have our opposite side. And beside theta, or next to, this is our adjacent side. And our reference angle is the angle that we will be using when we do calculations. And the opposite and the adjacent, I just said it, but I'm going to write it down here. These are named based on the reference angle. Okay, so now that we've learned to properly label our triangle with respect to a reference angle, we're going to take a look at what we call the primary trig ratios. And these are for right triangles only, and this is really important to remember because later on we will be looking at triangles that aren't right triangles, and these primary trig ratios will not apply to them. So what these primary trig ratios look at is the ratio of one side length to another side length with respect to an angle. All right, so if we quickly just look back at our triangle up here, we have our reference angle, and then these other three sides, they would have different lengths to them. And so these primary trig ratios look at that relationship and help us to calculate that relationship. So there are three primary trig ratios. There's sine, cosine, and tangent. And for short form, we can use SIN, which is still just called sine, or cos, COS, or tan, TAN. And so for sine, this is the ratio with respect to an angle of the opposite side to the hypotenuse. So we write it out like this: SIN of an angle, and I'm going to use theta again here. You could use a letter, you could use X if you wish, is equal to the opposite side, I'm going to use the short form of OPP there, over hypotenuse. So for cosine, it is the ratio of the adjacent side to the hypotenuse. So we would have cos of an angle is equal to ADJ, for short for adjacent, over hypotenuse, so HYP again. And for our tangent is the ratio of the opposite side to the adjacent side. So tan of theta is equal to the opposite over adjacent. So these are three primary trig ratios that we are going to be using in the first few lessons of this unit. And they are useful. We can take a look at the bottom statements here because when given two sides, we can solve for the reference angle. And when given a side and an angle, we can solve for another side. And I should put here that this other angle is in addition to the 90-degree angle. So before we get into sine, cos, and tan, we are going to look at Pythagorean Theorem, because this is something that you did in grade 7, or maybe not grade 7, but grade 8, grade 9. And so we're going to look at a little refresher here because it is a calculation that we can use with right triangles. So Pythagorean Theorem is c squared is equal to a squared plus b squared. So let's take a look at the triangle that we have below here. It is called A, B, and C, so that makes it easy for us. And you'll notice that side B has a lowercase b, right? So opposite side B, here's side B. So opposite side B, we have angle B. And so for the angles or the vertices of the triangle, we have uppercase. And then for the sides that are opposite them, we label them with a lowercase. So this would be side C. And down here below, this would be side A. So that's the proper way to label the sides on a triangle. So let's solve for side B using the Pythagorean theorem. So we start off with our formula, and we are going to put in 13 for c squared because this is always, c, this is always the hypotenuse. Okay, and then the other two are what we call the legs, or the other two sides that are not the hypotenuse. So we end up with 13 squared is equal to b squared. I don't know why I wrote b squared plus a squared, but doesn't matter. And then plus a squared, which is 5 squared. So 13 squared gives us 169. That's equal to b squared plus 25. We want to get b squared by itself. So we are going to subtract 25 from the left-hand side. And that gives us 144 is equal to b squared. Let's put this as proper form where we have our variable on the left. So we have b squared is equal to 144. And to get b by itself, we want to take the square root of 144. That is going to give us exactly 12. And we have our units here, which are millimeters. So we want to make sure that we always include the proper units. Now, in this case, we did not need to do any rounding, but whenever we are calculating for a side and looking for a side, we want to round to 1 decimal place. So round all side lengths to 1 decimal place unless told otherwise. So now we're going to get into actually using your calculator to do some calculations that involve the primary trig ratios. We're not going to actually put them in the context of the triangle just yet because this is just going to give us some practice on how to use our calculator. So on your calculator, you will have, and you have to have a scientific calculator for this. You can't do this with a non-scientific calculator. Now on your calculator, you will have 3 buttons. You will have a sine button, a cos, and a tan button. Okay, so you'll have 3 buttons that look like this. Now on some calculators, you would push this button, the sine button, before putting in the number. And on others, you'll put in the number before putting in sine. And there's going to be a separate video on how to use the 2 different types of calculators if you are having difficulty. But right now we just need to find these buttons and try and calculate along with me. So for question 1 here, we're going to evaluate and round to 4 decimal places. So we're literally just punching in sine 20 in our calculator. And we were going to round to 4 decimal places. And I think I'm gonna have to write below because I'm not sure I'm gonna have room to do it on these lines here. So sine 20 is going to give us approximately 0.3420, okay, if we round to 4 decimal places. Okay, let's do part B. So we have cos 20 here, and that is equal to approximately 0.9397. And lastly, we have part C, which is tan 20. So this is going to give us approximately 0.36397, and then on it goes. So just a little bit extra thinking involved here with the rounding, because we have the 9 and then we have the 7 here. So if we added 1 to the 9, that would make it a 10, and that would then change all of this right here. So this is going to be 0.364 and then 0 for 4 decimal places. Okay, let's look at example 2. This would be if you're solving for an unknown side length. Again, we're not even going to put the triangle here just yet, but this is just practicing how to do some calculations here and getting some good practice using our calculator. So part A, we have tan 40, and we don't split up the tan and the 40. They are like 1 unit. So we have tan 40 is equal to x divided by 3.5. So we want to find x. And on the right-hand side here, we have division, which means to get x by itself, we're going to do multiplication on the left-hand side. So we have 3.5 times tan 40 is equal to x. And we want to do proper form and get x on that left-hand side. But we're still just doing 3.5 times tan 40 on your calculator. And this should give you approximately 2.9. And I'll just put the word units here because we didn't give any other units. Okay, so you should be trying this along and making sure that you understand how to use your calculator. Let's look at part B. We have cos 61 is equal to 9.2 divided by x. Again, cos 61, this is treated as one entity. So on our right-hand side, we have division here. So to start to get x by itself, we want to use multiplication on the left-hand side. So you have x times cos 61, and that is equal to 9.2. Okay, x still isn't by itself, but we have multiplication on the left-hand side. And so we're going to use division on the right-hand side to get x by itself. So we have x is equal to 9.2 divided by cos 61. Now, when you're putting this into your calculator, a tip I can give you, and on some calculators it won't make any difference, and on some it will make all the difference, to maybe put some brackets around this cos of 61 as you are typing it into your calculator. So the answer you should get is that x is equal to approximately 19.0 units. Okay, and lastly, we are going to solve for an unknown angle and round to a whole number. And even though I thought I just fixed this, this has somehow moved, or not moved where I want it to go. Okay, so I'm going to just quickly write it here. So solve for the unknown angle and round to a whole number, because angles, when we get into actually doing the triangle, we will be rounding those to a whole number. Okay, so we want to round to a whole number. Looks like an H. All right, so this part is sometimes a little more difficult to punch into the calculator because I just talked about how sine x is like a whole entity, but we actually have to break up that entity in order to solve for x. Okay, so that's what we're going to be doing. We're going to break it up. So if you have that sine x is equal to 0.9876, this is how you're going to solve for x. You're going to write out your next step, which is x is equal to sine to the negative 1 bracket 0.9876. Okay, and on some of your calculators, you're going to be able to punch it in exactly how it looks. And on others, you're going to have to punch in the number first and then sine to the negative 1. So that sine to the negative 1, I am just going to write it down here. So sine to the negative 1, this is usually found above regular sine. So actually I'm going to get rid of that. So on your calculator, it is likely a second function. So we call this inverse sine, and you would call it also like inverse tan or inverse cos. And on your calculator, you probably need to use a second function button. So it might look like this, or it might say the word shift on it to access that inverse sine. Okay, so take a look at your calculator and calculate along. So if we punch this into our calculators, we should get, as a rounded number, so rounded to a whole, approximately 81. And it's going to be an angle, so we're going to put a degree symbol there. So units are important. Now let's take a look at B. So we have tan x is equal to 5.9 over, or divided by, 7.4. So our next line is going to look like this. X is equal to the inverse tan, or tan to the negative 1, bracket 5.9 over 7.4. And again, some of you will be able to punch it into your calculator exactly how it looks, and some of you will have to play around with it a little bit. So a tip is to always make sure you have these brackets, especially when you're punching in a fraction, because you should be able to put this all in one step in your calculator and not do it in multiple small steps. Okay, make sure you have the brackets here so that you're doing tan negative 1 of this entire thing, right? Not just of 5.9 and then after all that dividing by 7.4. So the answer you should get is approximately 39 degrees. Okay, so play around with your calculator and make sure you understand how to use it with respect to sine, cos, and tan, and inverse sine, inverse cos, and inverse tan.